Hello, everyone. I'm Frank, and welcome to Frank Puzzles. This is a new channel where I'm going to share my love of puzzles with all of you. My goal is to post at least one video every day, and I hope you enjoy watching my puzzle solving and listening to my thought processes. I fixed my mic problems that I had on previous puzzles by borrowing a mic from my sister. Thanks, sis. And hopefully, there won't be any other problems with the sound. Now, onto the puzzle. Okay, the puzzle is called Shifter Lines 106 Searching for 5 Seconds by Goobler. Normal Sudoku rules apply. Place the digits 1 through 9 in every empty cell, which means digits must not repeat within the same row, column, or box. Okay, that's one way of putting it. Shifter lines. Adjacent digits within the same box on the shifter line share both parity, that is even and oddness, and polarity, low and high. Whenever the line enters a new box, either the parity or the polarity shifts, never both. Shifter lines can never have a 5 on it. Digits may repeat on lines. So in these are the shifter lines, I guess. And within a box, so in the same box, adjacent digits must share the even and oddness and the polarity, the high and low. Whenever the line enters a new box, either the parity or the polarity shift, never both. Okay, interesting. So that means, say, like, these are both odd or whatever. Say, like, this was. Oh, they have to be the same parity and polarity. So this would have to be, like, say, 1, 3. And then either the polarity or the parity switches, but not both. So this could be either like shifting in parity, which would make it like a 2 or 4, or it could shift the polarity, which would make it a 7 or a 9, but never more than that. Interesting. Shifter lines can never have a 5 on it. Digits may repeat on line. Okay, shifters digits can never have a 5 on it. So that means it has to be 1 through 4 polarity. So there's basically no 5s. Okay. Next rule, crop key dots. Black dot between cells indicate cell values with a 2-to-1 ratio. Not all dots are shown. So that means if this were a 2, this would have to be a 1 or 4 because one has to be double the other. X. Adjacent cells connected with an X must sum to 10. Not all X's are shown. So that means these digits must add up to 10, which means if this was a 7, this would have to be a 3. Search 5. Each arrow points to the closest 5 where the digit on the arrow is how many cells away the 5 is. For example, let's say there's an arrow in R1C1, so it would be here, pointing to the right, so it would be pointing right. If R1C1 was 8, the 5 would have to be in R1C9. There may be multiple arrows pointing to the same 5, and it's not necessary for every 5 to have an arrow pointing to it. If R7, C7 was a 6, there would be a 5 in both R1C7, or that would be R1C7, and R7C1. There's a setting under visuals called draw arrows above lines, and I recommend you to set that to on. Okay, so draw arrows above lines. Okay, so then we can, but that didn't do it. Anyways, and those are the rules. I'm I'm going to have a link in the description where you can play along. And let's go. Okay. So one thing we know is there's no 5 on any of the lines. So that limits where the 5s can be. I'm not sure how helpful that is, actually. Why are these arrows being anyways? Whatever. Supposedly yeah, draw arrows above lines. It doesn't seem to be working very well. Oh, whatever. Okay, so this is, oh, interesting. This has to be 1 greater than that, right? Because these point to the same 5. So this has to be a 1 to 2 ratio. Therefore, we know, sorry, it has to be a difference of 1. And the only difference of 1 you could have for a double is 1 and 2. So this is 1, this is 2, which makes this. So because of the same polarity and parity, this has to be 4. This is a 5, so this is 1, which makes that 5. So this changed in parity, which is even oddness. So this is 3. And this one, this cannot have a 2 or 4. So if this were to change in parity, it would have to have a 2, and that's not possible. So this has to change in polarity, which means it has to be 7 and 9. So we know that's 7, 9. Okay. So this is 5, 1, 5. Okay, so this cannot be 5. These can't be 5. That can't obviously be 5. So this would have to be 6, 7, or 8. So if it's 6, so it cannot be 5. Okay, well, that can't be 5. Therefore, the 5 has to be here, right? Because we know this is a number. So this is a number, and it cannot be 1 because of that and that. And it can't be 5 here, and that can't be 5. So this has to be the 5, which means this is 1, 2, 3, 4, 5, 6, 7 away. So this is 7. Let's see. So this is 2 away. 1, 2. This is 1, 2, 3, 4. Right, that makes sense. So this must change either parity or polarity. This must change either parity or polarity. So this could be 6, 8, or it could be 1, 3. So 5 has to be this way, which means this is 5. So this has to be 2. So this is 2 and 4. Because the parity has to be the same. The polarity. So this is 1, 2, 3, 4. So this is 5. Which means this is 1, 2, 3. So this is 1. So this cannot be 1. Therefore, it cannot change polarity. Therefore, this has to be parity. Sorry, it can't change parity. So it has to change polarity. So that's 6 and 8. This again cannot be. I guess it could be 2 and 4 technically. We'll take a look at that. Okay, so we have all the 5s. Okay, so where are the 5s? I like coloring these in so that I can actually visualize it. So this cannot be a 5 because it's on the line, so therefore that has to be the 5. The 5 cannot be here, therefore this has to be the 5. None of these can be 5, therefore this is the 5. And since those are 5s, this has to be the 5 by Sudoku. So we know these are all the 5. This makes this a 2. This is 4, I believe. So it's 1, 2, 3, 4. Yep. So this has to be 2. Well, anyways. This cannot be 1 or 3. So that means it can't switch parity here. So the polarity has to change. So this is 6 or 8. Which means this is 3 or 4. So if this was 6 and it was 3, that would change both parity and polarity. So that cannot be 6. So this has to be 8. And that's 4. And this is 2. This can't be 1. So that's 1. This is 3. This is 2 and 4. So this has to be 8 because it can't be 2. This can't be 2, 8. Cannot be 4, 6. So this is 1, 9 or 3, 7. Whoops. So this is 1, 3, 7, 9, 1, 3, 7, 9. This cannot switch parity, so it has to switch polarity. So this is 7, 9. So this is 1 or 3. This is 7, 9. So this has to be 7 or 9 also. It cannot switch parity because it would have to be 6, 8 here. So this has to be polarity. So this is 1, 3. And we know, therefore, this is 3. This is 1. This could be 4 and 2. And that would have to be 2 and 4 if that's the case. It can't be 2. Can't be 4. So this cannot be 2 or 4, which means it has to be 7, 9. So we have all the 7, 9s here and here, which means these have to be 7, 9. This cannot be 1, 2, 1, 2, 4, 8. So it has to be 3, 6, which makes this 6 and this 3. So this is 1. This is 1. That's 9. This is 7. This is 9. This is 7. It cannot switch parity because that would be 2 and 4. So this has to be 7 and 9. So this is 9. This is 7. This is 7. This is 9. We have 7 and 9. This cannot. So this is 6 or 8. So actually, let's do first 9 and 7. This is 6 or 8 because it cannot be 1 or 3 when switching polarities, or sorry, parities. This is 6. It cannot switch polarity, so this has to be parity. So this is 7 or 9. Therefore, this is 9. And so that's a 1. And we're almost done. This can't be 2, so 2's over here. And therefore, this is 2. This is 8. And now it's pretty much just Sudoku. This is 3 or 6. Okay, so this is what we have here is we have 2. So it's 7 and 9. And there's also a 6. So this is 7. This is 9. This is 6. This has to be low. So that's 3. This is 6. This is 8. 3. We have 7 and 8. So this is 8, 7. This is 6. We have 2 and 4. So this is 2, 4. We have 4 and 6. And we have 1 and 8, I believe. 8, 1. This is 8. This is 3. We have 4, 6, 9. We have 3 and 6. And 8. And it's done. Well, hope you have fun. And I'll see you next time.